So we are dealing with the ninth problem in this series, and it is problem number 1.326. The problem is stating, on the opposite sides of a wide vertical vessel filled with water, two identical holes are opened, each having the cross-sectional area S equals 0.50 centimeter square. The height difference between them is equal to 51 centimeter. Find the resultant force of reaction of the water flowing out of the vessel. So if we represent this situation diagrammatically, then this is how we are going to represent it. That this is the vessel, it is having two openings V1 and V2, and the height of V1 from the open surface is H1 and V2 is H2. So discharge of fluid taking place from V1 will be equal to root 2g H1, and due to H2 the discharge velocity will be root 2g H2. Now because of this discharge of fluid, a force F is going to act in this direction, which is F1, and because of discharge of fluid from here, a reaction force F2 is going to act in this direction. Now the problem is asking us to find the resultant force of reaction of the water flowing out of the vessel. Now the first thing that we do is we want to calculate the reaction force when the fluid is discharged from a pipe or a hole. So we consider something like this. So if I consider a pipeline having cross-sectional area S, through which fluid flow is maintained with a velocity v, then in time dt, v dt segment of the fluid will flow out. So over here, if I write the rate of discharge of fluid, the rate of discharge of fluid dm, then we can write it as the volume enclosed with v dt. So v dt length multiply by area S. So this is the volume multiply by density. So this is the rate of discharge of fluid, that is dm. And if we calculate dm by dt from here, which is the rate of discharge of fluid, then it is equal to rho s v. So therefore the thrust force which is going to act on it is going to be v dm by dt, and v dm by dt equals rho s v square. So over here we can say from this result that we have that F1 and F2 are acting in the opposite direction, where F1 is going to be equal to rho s g h1. So v square over here, v value is 2g h1. So rho s v square 2 rho s g h1, and F2 is going to be 2 rho s g h2. Now since F1 and F2 are acting in the opposite direction and F2 is greater than F1, so the net force that we calculate is going to be F net equals F2 minus F1, and F2 minus F1 equals 2 rho s g h2 minus h1, that is 2 rho s g delta h. So this is the required answer for this particular problem. Now if we substitute the values which is given to us, so we will get the final answer. So 2 rho can be taken as 1000 kg per meter cube. S over here is 0.5 centimeter square. So by 10 to the power 4 to convert it in meter square. G delta H being 51 centimeter. And on solving we obtain this value as roughly coming out to be around 5 Newton. So this is the answer for this particular problem. 0.5 Newton is the answer which we are getting. On solving we are getting this value as 0.5 Newton. So this is the net force that we obtain for this particular problem.